opera-singing scientists of the My Sister's Room COVID laboratory in their rendition of the SARS-CoV-2 Tango.
RNA, RT, PCR, RT, lamp, uh-oh. RNA, RT, PCR, RT, lamp, uh-oh. Humans store their genetic information in material molecules of DNA. That DNA contains the genes that code for the proteins that determine almost everything about you. SARS-CoV-2, the virus at the center of this entire COVID-19 pandemic, actually stores its genetic information in RNA, which typically would carry the instructions from DNA for making proteins. The COVID-19 tests are used to pinpoint a specific gene, the N gene, that codes for the nucleocapsid protein, which is vital to viral assembly and transcription. But a patient sample, whether from saliva or from your nasopharynx, doesn't contain enough of the SARS-CoV-2 RNA for it to be detected. So the tests make many copies of the N gene in order to make it detectable by using RT-PCR, reverse transcription polymerase chain reaction. I'm going to tell you all about it. It's your lucky day. First, a DNA copy of the viral RNA N gene is made. DNA primers, which are short strands of DNA, target the N gene. Once the primer binds, the enzyme reverse transcriptase makes a strand of DNA nucleotides, the building blocks of DNA and RNA, that are complementary to the RNA strand, aka cDNA. The RNA is then removed and another DNA primer binds to the opposite end of that section of cDNA, and Taq DNA polymerase, another enzyme, binds and forms the second strand of cDNA. Now we have turned the viral RNA into DNA, but there's still not enough to be detectable. So we have to make lots of copies. The DNA copy is denatured into the two strands. Primers now attach to those DNA strand templates, and Taq polymerase forms another cDNA strand. And this happens again and again and again and again. The virus is finally detectable after 30 to 40 cycles, or when there are at least 1 billion DNA couples. There is an alternative way of testing, which, although not foolproof, is being studied and practiced. Reverse transcription loop-mediated isothermal amplification, or RT-LAMP, uses 4 to 6 primers that go to the target sections of viral RNA. Similarly to RT-PCR, reverse transcriptase starts converting the RNA to cDNA, and it gets repeated with the corresponding primers. What makes RT-LAMP different is that these new strands of DNA, as they get displaced, get looped into dumbbell shapes because of the reverse complementary sequences. The unique shape allows amplification to occur from multiple sites on the strands, making the detectability happen much faster, and it only requires heating and visual inspection, making it less complicated. So, although I couldn't offer peace of mind amid these scary and troubling times, I hopefully offered some scientific understanding, hope, and all that jazz.
COVID-19 testing, RT-PCR or RT-LAMP.